All right, so the next thing in our little mini lesson series is a review of exponential functions. And so as a quick reminder, when you're dealing with an exponential function, the variable x is now in the exponent. Okay, and our standard formula is a times b to the x, where that b value is your constant multiplier. This time we're constantly multiplying. And then this a value would be your starting value or your y-intercept. If you're dealing with something that is either growing or decaying by a percent, you know you need to have 1 plus or 1 minus when you are dealing with growth or decay by 8%. And so take that percent and divide it by 100 to get this decimal value for R. And then if it's a population that's growing by a percent, you would add it to 1. If it's decreasing, decaying, whatever word they're using, depreciating, you're going to subtract it from 1. Okay, so starting with example 1. You found 2 rabbits under your home. Each month they triple in numbers. How many rabbits will you have in 4 months? Okay, and so our starting value or our y-intercept is 2. Our constant multiplier is 3. And our variable, the time, would be 4. So we would do 2 times 3 to the 4th power. And typing that in, 2 times 3 to the 4th gives us 162. Okay, notice I didn't add 1 to this or add it to 1 because it's not a percent. Only deal with that when you see the word percent. Okay, find the value of an investment of 162 rabbits. Find the value of an investment of $8,500. That's our starting value after 5 years. If the interest rate is 8% per year compounded annually. Okay, so for this, 8,500 is the a value, and then 5 is the exponent. The time always goes up in the exponent. Okay, and so to figure out what's going here, we have a percent, and it's growing. It's earning interest. Okay, so I'm going to go ahead and write the 1 plus. Okay, now to get what I'm adding, as soon as you see percent, 8 is percent means per 100. Okay, so 8 divided by 100, and you want to leave that as a decimal 0.08. So 1 plus 0.08. Okay, you don't want to just leave it as 0.08. Anything smaller than 1 is going to decay, and that's going to decay very quickly. You have to add it to 1 in order to grow. So you can type that in your calculator. 8,500 times 1 plus 0.08 raised to the 5th power. Okay, and since this is money, we're going to round it to the nearest cent. And so 28, and then there's an 8 here. We're going to round that to 29 cents. And so 1, 2, 4, 8, 9, and 29 cents. All right, this is a STAAR question. A particular type of cell doubles in number every hour. Which function can be used to find the number of cells present at the end of h hours if there are initially 4 cells? So our a value is 4, our constant multiplier is 2, and then our exponent is h hours. Okay, if they put a 1/2 here, we're not cutting in half. Here they're trying to add. Here they're trying to add 1/2. So obviously B would be our answer. So some of these STAAR questions are going to be super easy for you. All right, a student used, hopefully you can see that. I'm going to zoom in a little bit just in case. A student used this function to show the balance in a savings account will increase over time. What does the 5 represent? Well, the 5 is the a value, so we know that's the initial amount. And so before even reading the options, I know I'm looking for something that says the initial amount. Okay, so choice A says the interest the savings account earned. That's not true. They're not earning $5 in interest each time. The annual interest rate, that's not true. That's not a rate. That's the starting value. The number of years, that would be X. The starting balance. Okay, so the annual interest rate that we're adding to 1 is 0.012. And so as a percent, it would be 1.2%. So that's how we know that's not correct. And then the number of years is represented by X here. Okay, and so the answer for this one is D. The 5 represents the starting amount because it's in the A position here. Right, what else we got? Oh, a table. The table shows the population P of mice in a field at the end of M months. Okay, so M is months, P is the population. Based on the data in the table, what will the population of mice be at the end of 5 months? Okay, and so 5 would be the very next value in the table. And so let's see if we can find a pattern. We go from 6 to 12, 12 to 24, 24 to 48. And so it looks like it's doubling. Times 2, times 2, times 2, times 2. And if you need to figure out what the constant multiplier is, take y2 and divide it by y1. And so in this case, y2 is 12, y1 is 6. That gives you 2. Sometimes it's a pretty number and obvious, like it is here. Sometimes it's not. So y2 divided by y1 will always get you the b value. Okay, and then the a value is right here, the y-intercept. And so if I needed an equation, our a value, our b value is the constant multiplier, our a value is 6, our b value is 2, and then we want to know after 5 months. Okay, so using the formula, 6 times 2 to the 5th. And so if they wanted like 10 months, that would be easy. So 192. You can also just keep the pattern going in the table. Take that 96 times 2 would give you the exact same answer. I just wrote the formula just in case it was like 10 months or 100 months. You wouldn't want to keep the pattern going all the way to 100 months. All right, Jessica decides to invest $4,000 into a money market earning 4% annual interest. Okay, so our starting value is 4,000 and we are earning a percentage, so 1 plus. And then 4%, type it in your calculator, is 0.04. And then we don't know how many years. And so we don't want A because they forgot to add it to 1. That is not going to grow. Here we've added it to 1. Here, I don't know what they're doing. Here they added 0.4, which is 40%. They didn't use their calculator to figure out 0.04. So the correct answer here is B, don't fall for their tricks. All right, more STAAR questions. Okay, the graph of an exponential function is shown on the grid. Based on the graph, which statement about the function is true? So it looks like we have statements about the range and the domain. Okay, and so anytime you're dealing with an exponential function, the domain is all real numbers. Always, okay? And so the domain is a set of all real numbers greater than -4. That is not true. The domain is a set of all real numbers less than -4. That is not true. It is all real numbers all the time. Okay, dealing with range, we have an asymptote here at y equals 0. And we have to draw an arrow up to see where our function is. The entire function is above this purple line, this asymptote. And so our y values are always going to be greater than It doesn't matter that it's decaying. All we care about is that it lies above the asymptote. And so y is greater than. Can't ever equal the asymptote. That's for quadratics. For exponential, you never equal. And so the range is a set of all numbers less than 0, not true. It is greater than 0 because it is above. Anytime you're above, you are greater than. All right, doctors measure the population growth of cells over a period of time. So here we've got the month, here we've got the number of cells. What would be the population, or what would be the approximate numbers of cells after 6 months? And so we can continue the table if we see the pattern. So here, 15 to 45, I think is multiplication by 3, but I'm not positive. And so I'm going to do the trick where you take y2 divided by y1, which is 45 divided by the 15, and just check. 45 divided by 15 is 3. And so I know to get to the next number, I need to multiply by 3. But let's double check and make sure 45 times 3 would give me 135. 45 times 3 gives me the 135. Multiply by 3 again gives me the 405. Times 3 again gives me the 1215. Okay, so if I multiply the 1215 times 3, 3, 6, 4, 5, multiply by 3 again, 10935. That is answer G because they wanted 6 months. Again, you could write an equation, or you could even use XBREG by putting it in your L1, L2 columns, and then doing stat calc option 0 is your XBREG. I like to just write the equation by hand, seeing that the starting value is 15, the constant multiplier is 3, and I want to know the value after 6 months. So 15 times 3 raised to the 6. Okay, remember this caret symbol is what gives you the exponent. Right, and that is it.